A striker is judged offside by 2 centimeters. The decision rewrites the result of the match, but the broadcast camera that adjudicated the call captured the world at 50 frames per second. In the 20 milliseconds between frames, a body moving at 10 meters per second travels 20 centimeters. The line is 2, the error is 30. This is the pixel fallacy. The belief that a digital image, because it is digital, represents an absolute truth. In reality, a video frame is an integration of light over a shutter interval, a record of where objects were smeared across exposure, sampled at a rate that cannot capture the dynamics of elite athleticism. Truth in officiating is not a software problem, it is a sensor problem. The sports technology market is flooded with wrappers, off-the-shelf object detectors applied to 50 Hz broadcast feeds. A wrapper inherits the limitations of its input. No amount of machine learning recovers temporal data that the sensor never captured. The kick itself is an impulse event that lasts 8 to 12 milliseconds. At 50 frames per second, the camera captures one frame before contact and the next frame after the ball has already left the foot. The operator picks the closest visible frame, draws a 1-pixel line, and adjudicates a 2-centimeter margin on an image physically outdated by dozens of centimeters. Veriprajna's answer is deep sensor fusion, 3 engineered layers that decouple the measurement of time from the measurement of space. Layer 1 is optical, 12 to 16 global shutter machine vision cameras fixed on stadium catwalks synchronized at 200 frames per second. Quadrupling the frame rate cuts the inter-frame interval from 20 milliseconds to 5. Motion blur falls from 10 centimeters to 2. The pose estimator is a custom network, SkelVP, built on an HRNet backbone with a dedicated offside head trained on 500,000 annotated frames. The spatio-temporal transformer enforces kinematic continuity, reconstructing occluded joints from the biomechanics of the running gait. Layer 2 is inertial. A high-frequency IMU is suspended in the volumetric center of the match ball, plus or minus 200G accelerometer, plus or minus 4,000 degrees per second gyroscope, sampled at 500 Hz. A high-pass filter isolates impact from rotation. The spectral signature separates the kick, a sharp spike with sub-2 millisecond rise time, from a bounce from a header. The IMU fixes the timestamp of contact to plus or minus 1 millisecond. Layer 3 is fusion. Precision time protocol synchronizes every camera and every sensor to sub-microsecond accuracy over a fiber optic backbone. An unscented Kalman filter smooths skeletal jitter against Newtonian physics. Cubic spline interpolation reconstructs the player's exact skeleton at the millisecond of contact, a virtual frame the camera never recorded. And a tightly coupled factor graph optimizer fuses raw vision residuals with raw inertial acceleration, solving for the single most likely state of the world. The math is unambiguous. At a relative velocity of 14 meters per second, a typical sprint against a stepping defender, the current system carries a temporal error of plus or minus 10 milliseconds. That translates to 14 centimeters of spatial error plus another 10 of motion blur. The zone of uncertainty, 30 to 40 centimeters. Under deep sensor fusion, the IMU defines the kick timestamp to plus or minus 1 millisecond. Movement in 1 millisecond at 14 meters per second is 1.4 centimeters. Cubic spline interpolation over a 5 millisecond window introduces less than 1 millimeter of additional error. The dominant remaining uncertainty is the SkelVP joint localization itself, 2 to 3 centimeters. Total zone of uncertainty, 2 to 3 centimeters, an order of magnitude reduction. The infrastructure is not cloud. 40 gigabytes per second of raw video processed across 4 edge compute nodes, each running dual A100 GPUs over RDMA over converged Ethernet, inside the stadium server room with a sub-5-second decision latency. The complaint that VAR ruins the game is not nostalgia, it is a correct engineering diagnosis. We are using a stopwatch to measure the speed of light, broadcast tools attempting scientific measurement. The fix is not to roll back the technology, the fix is to deepen it. Image intelligence becomes sensor intelligence. Once a stadium is digitized at this fidelity, the architecture pays for itself many times over. Handball adjudication by volumetric collision modeling. Injury prediction from cumulative joint load on the knee. Expected goals reweighted by impact velocity and body balance. Virtual broadcast replays from the eyes of the striker. We do not measure pixels, we measure truth. Read the 16-page brief on the geometry of truth, re-engineering officiating through deep sensor fusion.